Hello. So today I wanted to work on some more CHIP8 stuff. I specifically wanted to actually work on the keyboard input because right now, let me show you. Right now, if I am on the CPU, there are a couple of instructions I have yet to implement that have to do with key presses. So I figured, why not do the key press ones first? That seemed to kind of be the best one. The other instruction I haven't done is the implement, and that's because the frame buffer is really bare at the moment. That's a really nice way to put it. There's not much to it. So what I really want to do is I want to kind of flesh out the keyboard. The first approach I was thinking about was putting it on the CPU itself. The advantage of doing that is it's really easy to read it then because as you can see here in my execute, it actually takes a reference to the CPU. So I could easily just check the CPU, check the keys there, and see which one was pressed, etc., all that good stuff. But what I don't like about that is technically a keyboard's not part of a CPU, so it seems weird to put the keys on there. Of course the CPU talks to the keyboard, but that's kind of why I was thinking about instead putting it on in main. It's something that it's part of the emulator and it's something that interacts with the CPU. I just don't like the idea of putting it on the CPU for no reason. Well, not for no reason, but I don't like putting it on the CPU when I really feel like it shouldn't be on the CPU. So I don't think I'm going to go with that approach. I don't like putting it on the CPU. But I don't know. I'm debating it. I was also looking up over here. I'll bring it because I don't know much about ncurses. So one thing I find, I'm looking at input because right now in order to get user input, there are a couple things I need to do here. Returned immediately. So I think we have C break here because there's no buffering. If you've called C break, each key the user hits is returned immediately. We haven't done that. Otherwise, key step by the user will be queued until a new line is read. So I didn't know this, but I guess ncurses kind of has a queue in the background for the input buffer, which is fine. That actually helps me out because then I don't have to worry about queuing those up. I can basically take them as I need them. That's actually, yeah, that's really good then. The other thing here is no delay, because right now, so if I do this and I have a debug mode, right now it's, as you can see here by the get character, it's delayed. It's waiting for me to do something. But it looks like we can actually undo it here, which is really nice. I was also looking at this one for keyboard. This was just another specification, but it seems even more bare than what I have here. So I'm just going to ignore that. Anyways, this kind of just runs through it. So I need to basically set it up so it's not blocking in this case. I still want it for when it's debugging because having it, oh, that's nice for debugging because then I can step, take a look, step, take a look. So instead what I'm going to do, so this basically says waits until the key is hit, but if you have no delay with the source, so and you set it to true, then getCH will work in a non-blocking manner. So let's try that. So first we're going to do no delay. std in is what we're using, and I don't have any booleans. I'm not sure if it's defined in ncurses, so we're going to just simply try that. Oh, takes in the window and a boolean. I'm going to actually just see if that's defined Yeah, it is. I guess ncurses has true. I didn't define it anywhere. Cool. Okay. So make run, and now it's just going to exit because there's nothing waiting for us here. What we can do though is we can kind of set up the oops. We can set up the main loop here. Fetch to code execute here. And CPU is set up outside of that. So fetch, decode, execute. We're not printing things there. Free the instruction. We're not doing that. And then this is a way that we can get the character. Then we refresh the window. Let's just see if that runs. Let's see, it's unused. I don't like warnings if at all possible. And now this just runs forever. There's my output all being written out to the very top. Enter, it just throws a border around it and then does those things. Let's keep reading about this. Wait till key is hit. If you've called this, then get ch will work in a non-blocking manner. It will return error if the key input is not ready. This is useful for running game-like programs where promptness of user response matters. So maybe we can do something like what they have here in the example. So if ch is an error, then we can basically print something that says it's not good. So, refresh. Let's do it. So basically here we can, let's actually just put this at the top then. So we'll say if c as get ch is, no, that's right. If it's an error, we're going to print buffer not ready. Or what did they say? No user response. It means there's nothing in the queue. Else we're just gonna put yeah, we'll print their character. And then we're gonna continue doing these things. Build. Oops, did I add an extra C in there? I think I did. I most definitely did. C is undeclared. I guess I undefined it. I need no echo. Yeah, no echoing. So, no delay, no echo. Yeah, I was gonna say no arguments, but this cbreak takes it's a type void and whatever. It doesn't take any arguments. So let's rebuild. Let's try it again. Cool. I am taking user input in. That is awesome. Okay. Very cool. So now we have no echo. There's no delay in it, and then we can basically get the user input. Now we basically want to check whether or not this user input is valid, because there is only 16 keys that the user can take in. I'm just thinking about how exactly I want to do that. This is an older version. That's probably fine. My instinct is to make a module for keyboard and to basically put keyboard H and keyboard C. Yeah, basically make a module out of it and then have the valid keys put on that. But the problem with that, I think, is it's unnecessary, really. I'm just kind of making this extra module. But I do think it keeps it clean. And then there's something where it's basically like you can get the user input, check if it's valid, and then pass it to the CPU. So we're going to need something on the CPU that takes it anyways. These are all for my debugging things. Program into memory. So I'm thinking maybe here it can be something where it's like set key press or something like that, because we look at the CHIP8 thing here, there's a couple of them like right here. Skip the next instruction if the key with the value of this is not pressed. Okay, so if that's the case, then we can do something like set key pressed. And then we'll basically say key. Really fast though. So here it's basically set key press. Now over here on CPU H, we're going to basically have a key. I don't like it there. Those are all registers. That's better. Users key press, something like that. And then back over here, we need to go to the top and initialize it essentially. So then we do key is, we're just going to make it null. That's fine. And so this is just a nice way to set the user's key. So we're going to say CPU key is equal to key. And then we basically then need some way to figure out whether or not it was a valid key that the user pressed. Well, if this is an emulator, I actually think that's unnecessary. We'll just do that here. And we're going to map the keys. So let's do something like this, where we basically can say, let's first do this. Key, unknown type key. Oops. Oops. I also didn't mean to run the debug. I just recently changed the makefile commands I have, so I'm used to debug just doing two things at once. So, and then run, all this fun stuff, and then debug, still works as normal. Cool. So what exactly have we done on CPU? So, so this was the, so here we're adding, added, I like that better because the keyboard isn't part of the CPU, so there's really, it looks weird to put it on there to me. And then here what we added was, we actually just fleshed out what the regular run mode is. Added run mode, or expanded non, that's not the right way to put it. These colors are horrible. The yellow and white. I'll probably change that at some point. Expanded on debug mode to read. Yeah. I think that's pretty straight. Yeah. Cool. So we have a way to basically set the keyboard press. And so now over here, we're going to basically say, so here, the keyboard input is 4x4, so there's 16, but obviously, like, my keypad layout is nothing like that. I actually think there's something special for keypads for ncurses. Anyways, the keypad needs to be a 4x4, so it's a 16. I think using just the 1 through 4 in QWER, ASDF, and ZXCV is good enough as a mapping for that. So we can basically just check to see so do we want a helper function? I'll basically check whether or not, that's actually really easy to do. We'll just do that. I'm going to just make I'll just return it in. I should probably just define booleans, but this is fine. So if keyboard put valid, and I'll basically take in I'll take in a character, and then what we're going to do is we're going to say that switch on C, case 1, 2, 3, 4, 2, 3, 4, Q, W, E, R, A, S, D, F, Z, X, C, V, and we're going to return 1 in all those cases. Default will just be return 0. Keep making that typo. Oh, I guess I'm just prototyping them at the top here. Valid, I don't like that keyboard input valid. That just reads very odd. Valid keyboard input. I think that reads better. So if it's an error or it's an invalid valid keyboard input, no response. Otherwise, so it should only write 1 through 4, QWER, and those things. So build, what did I do here? I think I have an extra parenthesis. I most definitely do. Alright, so that compiles, run. Now it should only take in these characters. Yep, and if I do one of these other ones, oh, it's, 2, yeah. And it doesn't clear the whole buffer, but it's still there, so. I kind of want to move it here, so that way I can see invalid input. I think that's a little clearer. So these are all the valid inputs, and then if I do like a P, invalid, cool. Very cool. Okay, so, no, we'll do here. So, that's why I check. I can't stand those little things. Just dangling spaces. Looks good. Okay. Added helper function. Only valid O through 9, or we'll just say O through F characters map to well, it's a map side of the keyboard, so we basically did it as that. And then because the keyboard has it here is 1, 2, 3, C. Wrong one. 4, 5, 6, D. 4, 5, 6, D. Seven, 8, 9, E. I keep tapping to the wrong thing. A0BF. Okay. A0BF. Cool. That's our mapping, and then CHIP8 spec. Will be read and passed to the CPU. Cool. So now that we have that, I want to now that we have that, I'm going to basically come back up here, and then if it's valid, just for debugging, I'll put that here. But now we can do, and what did we call it back here? We never added it here. We basically had, we added the key there, but we never, that looked ugly. Where did I put it? I put it under the execute and before the get register. Set key press. Okay. I'll probably have to add something on the CPU that basically lets us know whether or not the key press has been processed. Because here's a diagram. I should probably just call it key press, rather than having this this comment about what it is. And then, yeah, I think that's actually clear. Because here, hold load hold instruction has it here. It's been processed, and then it continues. Okay. Yeah. So here we're basically setting the CPU key press. It's going to be useless in our debug mode. Yeah, it's going to be useless in our debug mode. I had to think about that for a second. So back to CHIP8. So now what we can do is set key press on the CPU. C. I'm going to keep it a C for now. Okay, cool. So, CPU.c. Oops. What line was that? 23. Yep. Reaches the end of a 604 on. Oops. My Vim key bindings are showing. Oh. Yeah, that shouldn't. I guess I was gonna basically have it where the key press is taken in and then we're validating it there, but there's really no point. We can validate it on. Yeah, we're validating it right here. Okay, so we'll set the key press there. Now everything should build just fine. It does. Cool. Yeah, okay. Cool. That's good. And then what we can do here is we can basically, so we have the key presses here, and we've set the key presses. Now we can go back to the CPU and we can finish the things that have to do with the key press. Wait for a key press and store it here. If this is the instruction, we don't have to wait for a key press. We can just, okay, so we're going to basically say set register, because the key press, we don't have to wait for it. We just got it. Set it on the CPU. The instruction is a and then we'll do CPU key press break. That was the first one. Now we got 2 more. So we're going to check to see if, so we're going to get that registered VX, and we're going to check if the key with the value of VX, so VX is equal to CPU key press, then we're going to do increment PC, check if the key, and if it is, increment it by 2. Perfect. And then we're basically doing the same thing, but in reverse. If VX doesn't equal the key press, increment PC. Oh, I need a reference to the CPU on each of them. Huh. Forgot this isn't C++. Cool. Alright, awesome. Make run. Take that input. That's all being set over there. There's no way to nicely exit that. And then make debug here. And perfect. We can still step through, and I'm still printing the instructions just fine. So one last thing to do is on the CPU, we basically renamed key press. We incremented that. What am I doing? I just confused myself while doing that. Okay, so then basically what we did here was we finished adding instructions with key presses, rename key, we renamed key to key press on the CPU. Fix the set key press function to no longer return an int. And then the last thing we did was implement skpvx, sknpvx instruction, and then implement ldvxk instruction, which is load the key value, wait for a key press and load it into VX. Cool. That was that. And then CHIP8 was, and then all I did here was basically set the key press from ncurses, set the key press yeah, that's fine. I was just gonna basically capitalize set, but there's really no reason to. Perfect. Okay. That's going to be it for today. I feel I got the key presses, and I was able to read them in from the input from ncurses and then pass them to the CPU, and now my execute instructions can actually handle them. So thanks a lot for watching.